Don Adams, please call B205. Dawn, please call B205.
So I wanted to make sure I went over a few things for your project so that you had a chance to look things up if you needed to. So in your project, you're going to be working with the Pythagorean theorem, and there's two ways to really use the Pythagorean theorem. The first way is to find, hold on. Where do we want here? To find a side. Okay, go up a little bit. So if I'm given a right triangle and I want to find one of the sides,
would a custodian please meet a student at B414? Custodian, meet a student at B414. Thank you.
I'd use the Pythagorean theorem. And the hypotenuse is always the side across from the right angle. So here's the right angle, the side across from it is x. So
would a second shift custodian please come to the main office? Second shift custodian to the main office, please.
So I want to find C. C is always the hypotenuse. It's always across from the right angle. So I'd put in 12 for A, 5 for B, and X for C. Notice how I switched up the A and B here. It really doesn't matter which side we call A or B, as long as it's not the hypotenuse. So either side that touches the right angle can be A or B. So 12 squared is 144. 5 squared is 25. X squared is x squared. So I take the square root of both sides, and the positive value is 13. Okay. If I wanted to do one here where the hypotenuse was one of the things I know, again I label it A, B, C, where C is the hypotenuse. Okay. And I know the A value, I don't know the B value, and I know the C value. Fill all those in, I get 9 plus B squared equals 25. I want to subtract 9 from both sides. Whatever I do to one side, I have to do the same thing to the other. B squared is 16. Take the square root of both sides, and the positive value is 4. So B is 4. Okay. The other thing I can use the Pythagorean theorem for is to check to see if a triangle is a right triangle. So let's say I was given the sides 6, 8, and 10. And I wanted to know, is this a right triangle? Well, here's how I would do it. I'd use the Pythagorean theorem, and I'd plug in the longest side will always be the hypotenuse, and the two shorter sides are A and B. This is 64, or 36 plus 64 equals 100. Well, 100 equals 100, so this is a right triangle. Okay. So maybe try another set of numbers. Maybe we'll do 15, 9, and 7. Is this a right triangle? Okay, so I do 7 squared plus 9 squared by is 15 squared. 7 squared is 49. 9 squared is 81. 15 squared is 225. Well, 49 plus 81, that's 130. That is not equal to 225, so this is not a right triangle. Okay. Another thing I can use the Pythagorean theorem for is distance. So let's say I'm working on the Cartesian coordinate. I wanted to find the distance between 1, 2, 3, 4, 4, comma 2, and negative 3, comma whatever this is up here. 1, 2, 3, 1, 2, 3, 4, 5, 6, negative 3, comma 6. I wanted to know the length of this line. Well, what I would do is I would actually make a right triangle. And I would figure out what this length is and what this length is, and then use the Pythagorean theorem to figure out this length. So I'm going to do the x value squared plus the distance in the y value squared equals the distance squared. So here are my x values, here are my y values, here's my right angle, and here's my distance. So I have to find the change in the x values. So I'm going to do x1 minus x2 plus y1 minus y2 equals distance squared. So x1 minus x2 squared plus y1 minus y2 squared is the distance squared. I'll zoom in a little bit so you guys can see a little bit better. Okay. So here's x1, y1, here's x2, y2. So I'm going to do 4 minus negative 3 squared plus 2 minus 6 squared is my distance squared. Okay, so 4 minus negative 3 is 7 squared. 2 minus 6 is negative 4 squared. That's my distance squared. So 7 squared is 49. Negative 4 squared is 16. So 49 plus 16 would be 55, plus 10 more is 65. So I'm going to take the square root of both sides, and now I want to find the square root of 65. So I want to know, can that be simplified? So I'm going to find the factors of 65. It's 13 and 5, and there's no perfect squares in there, so that's the simplest radical form. Okay. Quick note about simplest radical form. I won't worry about simplest radical form. I don't think you really need it. If you do need it, Google simplest radical form and you will find a tutorial on how to do it. It's pretty straightforward. You should remember it from middle school, from algebra anyways. But I don't think you need it for your project. So that's any extra information you might need for your project. The project also explains how to do most of this. Enjoy. I hope you have fun doing it. It's kind of a cool project. I had fun doing it. Have a happy holiday season and enjoy your time off.